Well, hello everyone. It's nice to meet you now in this course in machine learning, which I think is probably one of the most interesting and amazing topics that you could be studying. And so I'm really grateful for that. Sorry for the change. We'll definitely want to be praying for Dr. Lou Ron that she's doing okay. And if there's anybody that you have easy access to, if they didn't realize that we're doing this via Zoom, if you could reach out to them, that would be great. But let me go ahead and open up in prayer, and I'll give you a sense of the things that we're going to be covering. So, dear Heavenly Father, Lord, thank you for the chance to be able to visit with these students in this wonderful course, Machine Learning. I pray that this will be an interesting topic that everybody can value from it. It's going to be helpful for them in their future as they navigate towards their future job or starting a company of their choice. We also pray that you would be with Dr. Ludron, that you would heal her, Lord, and that she can be back with us shortly. And also, Lord, just help them in their all the students in their spiritual formation, Lord, all the things that they are learning about Scripture, about your ways, dear Lord, will be cherished in their heart and used now as well as in the future. In Jesus' precious name we pray. Amen. So let me just do a quick ping. So if some of you guys could maybe just give them a thumbs up or whatever, if you do know some other folks, just give them a heads up that we are on this link. There was some confusion about which link to use. And when I tried to log into that, I did not have host rights. And so I had to use this last minute. So thank you in advance for folks that are trying to reach out to other folks. So I'll give a little bit of a context. This is also going to be recorded in case there is confusion and people aren't able to get on in the next few minutes. And so you have looked at a lot of different techniques in this course, and this is one of those, and I'll get a chance to be providing some information on that. But I like this centric way of thinking about where we land in this kind of a topic. And so machine learning is a subset of artificial intelligence, and you're getting a chance to learn a variety of techniques. And even below that is another area, which is deep learning. And for folks that may be enamored with Chat GPT or some of these really sophisticated techniques, that's something that's kind of dwelling down into this deep learning area. It's not what we're going to cover today, but I wanted to give that perspective. But over here, this is what we're looking at, K nearest neighbors. And so we pick how many neighbors we're going to use to assess what's going to be happening at a new point. And we'll see this a couple times when I go over some material here, but it's best to have an odd number that we query so that we don't end up getting a tie. And so thus we're trying to figure out, where does this point go? Does it go into category A or category B? And basically we're using information from two different labels, two different characteristics of this to make that decision. And so that's roughly the real high level view of what we're going to cover. But there's three things we're going to get into. First of all, I'm going to go over the PDF summary for the K nearest neighbor that you have in Canvas. It's actually pretty good. And so I think that's a good way to get started. But then I also want to provide a different summary from a resource that I was able to leverage. And this will not only cover KNN, but also sklearn, which is one of the things that you can be using in your notebooks. And we'll get into that. And finally, we'll go over some notebooks. The first one is one that you have, and there's also another one that Dr. Ron made available. And what I'm using for my IDE, some of you may be using this. I use Google Colab. There's a lot of other ways you could do this. And there was a little bit of modification to some of the code I had to make to make that work. So let me go ahead and switch over to, well, first of all, since I have this up, you're all familiar with this, just the amazing things that you have learned. And so basically, there's a lot of different languages that you could do machine learning in. And so Python is really has done a wonderful job in giving some really good resources and continue to extend them. You could use MATLAB. There's other types of things that you could use. And so first things that you got a chance to get introduced to was some of these basic things, focusing on Python related areas, but also how you can be using that in a notebook, which is a really powerful tool. So a couple different plotting libraries, Matplotlib and Seaborn. Seaborn has a lot more flexibility, and so I'm sure you enjoyed getting a chance to see that. Then you got into some of these areas of machine learning, thinking about linear regression. That's an important area. So you had that over a couple of thematic areas. And so simple linear regression, and then regression performance evaluation. So each of these methods, you want to be thinking about what you're using and how it actually gets you from point A to point B the way you would like. You got a chance to be talking a little bit more in regression, polynomial regression, regularization, then logistic regression and classification. And so classification is going to be a key element to what we're going to be looking at when we talk about K nearest neighbors, which is the focus of what we have to today. And finally, you're going to get a chance to be looking at decision trees, which is also quite interesting. Okay, well, let me circle over to this handout. And so this is something that you have in Canvas. And why don't we just do a quick round the virtual room. How many people have found this resource in Canvas? You can just give me a thumbs up if you're already aware of that. So, and if you haven't, these handouts I think are quite done quite well. And so I would definitely encourage you to take advantage of that. So give me a second here. Advantage of it. So it's a simple machine learning algorithm that can be used for both classification and regression. And we're going to be focusing on classification. So keep that in mind. So what is the theory and some of the intuition? And so this one, at least for two-dimensional, it's easy enough for us to get a sense of what we're actually talking about. And so the KNN approach simply assigns a label to a new data based on the distance between the old data. So that would be the training data and the new data. And I think now you've gotten familiar with that you want to reserve portion of your data to help you get a good sense of what you then can apply to some new information and continue to have it make sense. So what's the intuition that we can be using for this? And so in this handout that you have is trying to determine what the sex of a chicken is. And so it tends to be a manual process. And so what could you do if you say we're going to be using the height and the weight to determine which sex they are? Is it actually possible that you could do this? Well, this is for the sake of what we're covering now. Let's assume that you can. And so we can have a data set of chicken height and weights. And so you can see this rough accumulation. And if you get this clustering, it might be something that you could say that this actually could work, that the females tend to be way less and are smaller. And so if you had one biometric of weight and another biometric of height, we could then make the distinction between these two categories. So what happens if we get a new member that's going to be put into that group that we want to classify? And so we can see this. Anybody wants to guess, would it be easier to classify that as a male or a female?
It would be in the female.
Female.
Yeah. Yeah, this is kind of an easy example just to see how you would do that. But if we want to come up with an automated method, and so we're using the nearest neighbors, you can see that, well, it's going to be pretty easy. And since we don't want to get a tie, using an odd number is really the way to go. You can see that all three of these are all in the female category. So that's going to be a fairly straightforward one. Okay, so we could prove that makes sense, but what happens when we get into this middle ground? And this is where it gets difficult when you're starting to get overlapping of of these groupings. And so it's not as clear to know if this would be male or female. But if we have an algorithm does things fairly rigorously and using the same rules, we'll at least be able to come up with an answer. So we have that situation, but what if we have a sparse data population? We have more in the male versus less in the female, and so that would be something that we could be thinking about. So in this case, the closest point is female. So if we were just going to use k is equal to 1, that would be the choice that we're going to be using. And we're going to be coming back to that in a few minutes, so keep that in mind. So what happens if we get, if we have 2, once again, the closest 2 are female. And so since we don't have a tie, we could still be using this, but there are some disadvantages of using a even number. So once again, now we're using 3, so we have 2 female and 1 male. So once again, the algorithm majority vote is not unanimous, but it's still showing the majority vote is showing that it's female. Now we get into the problem. What happens if we have a tie? So there's 2 male and 2 female, so it's ambiguous. Is it male or is it female? And so here are the various ways that we can do it. We can always choose an odd k. That would be a way of not having that issue. Or if we have a tie, we simply reduce k by 1. That would be making it an odd number. You could randomly break the tie, or you could assign the class of the nearest neighbor, which is equivalent to saying reducing k to 1. And this is a method is used by sklearn or scikit-learn. Those are the 2 ways that is called. So we get a tie here, and then we just we break that tie. And so the scikit-learn approach is just to reduce k to 1, and we get that value. So thus we declare that that's female. So that just gives you a sense of how that would work. K equals 5, we're getting more neighbors, but now this is the same example we had before. Instead of it classifying as female, and maybe you have a gut feeling, do you think this is male or female? But with 5, we actually get 3 male, and so then it flips over. Then we get into the issue, is it right? Is it actually male or is it actually female? And that would be another thing we want to be doing, is how we evaluate the performance of an algorithm. So we want a k value that minimizes error rate, where the error rate is equal to 1 minus the accuracy. So there's a relationship between accuracy here and error rate. And there's a couple different methods we can use. The elbow method, and we'll see these in the scripts, the notebooks that we'll see at in a few minutes. But we also have the cross-validated grip search is another approach. So the elbow is, you can see this, it's like, when does it minimize out? And so here is the localized minimum. And so we have a value of k equals 9. And then we have another one, an elbow down here is k equals to 22. But is it actually worth it to have this greater complexity of an algorithm to go from 9 to 22? Just to get a slightly improved error rate. And so that's a trade-off, but most likely it's not going to be worth it. So something a little bit more complicated is a cross-validated grid search. And so this is a combination with a grid search of multiple k values. It chooses the k value that results in the lowest error rate across multiple folds. So this could end up resulting in a more complex model, so a higher k value compared to the elbow method. So I say the elbow method is probably a little bit easier for you to understand, and so at least get that intuitive sense of how that would work. So the KNN algorithm is choose a K value. This is a hyperparameter, and I'll get into that in a little bit, value using the elbow method or cross-validated grid search. And so let's just say that we use the elbow method. We'll be seeing that in our notebooks. We sort the training points by distance to a new point. We assign a class to a new point based on the K nearest neighbor training points. And step two can be slow for a large number of training points. And so that's one of the things we want to be careful about. So we have an example. And so say we have 6 training points. And so once we see that there, and so then we can sort the training points by the distance to the new point. And so it goes 0, 1, 1, 0, 1, 1 as we go from closest to farthest away. And so what is a predicted value for a new point when k equals 1? So k equals 1, it just uses this closest value. And so the answer would be 0. So what is the predicted label for a new point when k equals 2? And so this is where we get this point where we have a tie. And so what this means is, well, the sklearn, it reverts back down to a k equals 1, and it chooses the first one. What if we have k equals 3? So we have 0, 1, 1. And so a voting scheme, we have 2 that say it's a 1, and one of them that says a 0, so we go with the 1. Well, how do we determine how far a point is from its nearest neighbors? And so there are 3 different approaches. I think you'll see that Euclidean is easy for us to comprehend, but there's also these other 2. So first of all, the Euclidean, we can just see that we use the Euclidean distance. So the square of the difference in the x, the square of the difference in the y, take the square root of that, and then that's where we get this value d. Well, the Manhattan distance gives a slightly different way, and why would we consider this? This is how much traversing you have to go from that one point, and so maybe this is overestimating the distance. But it's another method that would have its places where it would perform better. So you have to be thinking about, well, what kind of data that you have, and all that. And the Minkowski distance is a generalization of the Euclidean and the Manhattan distance. I'm not going to get into this in detail, but just you can be thinking of 2 examples. P equals 1, it's a Manhattan distance. What that means is it just would be that you don't have a y component. Maybe that's one way of thinking about it. And Euclidean would be p equals 2. You're going to see that it's going to be the same as that. So another important thing to be doing, and this is also something that you can do with sklearn, is to normalize the data. If you have these features way over here and way over there, you're going to be diminishing things because they aren't scaled properly. But if you have this kind of a way of looking at it, so you normalize them in such a way that you got a better sense of like this, you're going to get much better performance in using your classification by using KNN. So there are important considerations for KNN is it looking at the scaling and choosing the optimal K value. And we'll get a chance to be seeing that with our sample notebooks in a few minutes. So I think that's what I wanted to be covering there. You guys, I think some of you, maybe all of you have already seen this resource. And so let me just pause and see if there's any comments or questions about that. How about a thumbs up if you're tracking? Does this make sense? Okay, good. Well, let's go over back to my PowerPoint charts, and I'm going to share a little bit more now on a slightly different approach to be thinking about KNN. And so a little bit of repetition, but before I do that, let me go ahead and give a little bit of an overview of machine learning. And so really, if you wanted to learn machine learning, and I think you guys have been doing that in this course, is you want to get an idea, an introduction to the kind of capabilities and things that you can be doing. Then getting into the programming, one way of thinking about it is there's these three general ways of having a model. KNN, which is an example of classification. You can have linear regression and you can have logistic regression. And so classification and regression, and there's two types of regression that you've got a chance to be thinking about. But there's also some more in-depth topics, and I alluded to this earlier. You can have things where you have multi-layers of a machine learning approach. It gets into another area that I'm interested in, was neuromorphic computing, which is more focused on the hardware sense of what you could be doing with deep learning. And a lot of these algorithms which you have with ChatGPT, they use those multi layers of what you be using for creating a neural net or something like that. Computer vision is another example, and also natural language processing. And so with deep learning algorithms and also an application for natural language processing, this is where you can be getting the kind of capabilities that you're seeing with ChatGPT. Just to give you an example, it's not ChatGPT, but here is using Microsoft's Copilot example. And I put in this phrase, what is machine learning? And this is what it said. And I'm just going to highlight a few points, and then we'll get more specifically into KNN. And so machine learning is a field of study within artificial intelligence. And you remember those circles that I showed earlier that focuses on creating systems and algorithms that allow computers to learn from and make decisions. My mouse is a little squirrely here. To learn from and make decisions or prediction based on the data. So it has a level of programmed, quote, intelligence that it's able to replicate those things again and again. So instead of being explicitly programmed with specific instructions, machine learning models identify patterns and relationships in data to improve their performance over time. And so this is a slightly different way of giving you these perspective, but here are the four types that they thought were noteworthy to have us think about: supervised learning, unsupervised learning, reinforcement learning, and then they have this hybrid semi-supervised and self-supervised learning. So supervised learning is the model is trained on labels, meaning the inputs are paired with the correct outputs. For example, teaching a model to recognize something. And I'm going to be showing you an example with cats, and so it's interesting that that's what Copilot came up with, and it's actually going to be something I'm going to show. So a true positive would be that you say it's a cat and it is a cat. And so there's going to be four categories that, and also the other end of it would be that if it's a false and it definitely is not a cat, you want to be able to detect those. But then you have these ones where it labels it. That's also something you want to be aware of. Unsupervised learning, the model works with unlabeled data and tries to uncover patterns or groupings. And so on its own, it tries to find that. So clustering customer data to understand market segments. And so maybe by reformatting the data in one form or another, or having some kind of a factor you apply to it, you can start to see those clusters. Reinforcement learning, the model learns by interacting with its environment and receives rewards or penalties for its actions. And so learning, the models can actually learn. So you can train AI to play chess, for example. And then semi-supervised and self-supervised learning, these approaches use a mix of labeled and unlabeled data or create labels from raw data to achieve learning. So interesting to be thinking about it. And so how did Copilot come up with this? Basically, it's constantly surveying what are the information that would be associated with this, compile that, and come up with this aggregation. And so machine learning is used in many applications. So recommendation systems, self-driving cars, fraud detection, image recognition, and much more. When I took my training in machine learning, looking at medical image diagnostics, trying to determine if there's cancer or something like that, just to give you one area that is interesting. And self-driving cars, we're getting pretty close to having total autonomy. It's just short of that of what is allowed on the open highways and roads. And it's definitely is a rapidly evolving field. And so it's pretty hard for textbook to stay up with the latest development of what's out there. So KNN, what we're going to be focusing on is classification. And so it's a supervised learning algorithm that classifies as new data points based on which training data points they're closest to. And so KNN assumes that the closer data points are more similar to each other. And so thus we're trying to come up with those criteria to be thinking about it. So you can think of a medical example. I mentioned this earlier. So classification is a task of splitting or organizing data into different classes based on features of the data. So you can be selecting certain features. For example, a doctor might want to classify a patient as either sick or healthy, using information like if they have a sore throat or fever, all of those things. And so basically, if you thought these were the two parameters, sore throat and fever, if those were both true, they would be sick. And if they're both negative, then they would be healthy. Well, there's types of classification. You can have a binary classification. So a spam filter would be that. It's either it is spam or it's not. You can have multi-class classification and saying that you're trying to do optical character recognition. So you're trying to see someone hand wrote a address for an envelope being sent in the US mail. You would want to be figuring out which one it is. And so here we're showing a correct detection that it's a 2, then that's what you're seeing here in the script. So if there was a little bit of more variability, the error rate would go up. Or you could have multi-label classifications. It organizes each instance of a data into multiple categories out of many options. And so those are some examples of the things that we have here. So what are we trying to do with KNN? We have this new data point. We don't know which group to put it in. And after we have the nearest neighbor algorithm, we come up to a decision. And you could probably eyeball this one and say, yeah, it's definitely in this group, but you're trying to have the machine do it. And so it's not necessarily going to have this vantage point of the way that we are using this two-dimensional way of visualizing this data to come up with. And what if you have more than 3 dimensions? We can't visualize it, but the algorithms could still be used. And that's something for us to be considering. So here is one example is like, say, our two characterizations we're going to be considering is weight and height. And so we're going to try and determine from those if something is a cat versus a fish. And so you can see that, well, you would think in general that the fish would not weigh as much, but here an example of this goldfish. I recently saw a news report where it said somebody just let their goldfish go into a pond, and it got to be a huge goldfish. And so it may seem a little bit strange, but now you can see that there's a little bit of ambiguity. There's not this clear, distinct groupings. And so that's, we have to be a little bit more meticulous about thinking where we're going to be classifying that group. So when we get a new data point, the model computes the distance to every training data point. The model then looks at the class of the K nearest training. And so 1, 2, 3, 4, 5, 6. This isn't the best way to do it because there's 6. So you want to be using a odd number. So here we're not going to be able to make a decision because they're the same. The same for class A and the same for class B that they're determining. Then the model takes a majority vote of these classes and returns the result as its prediction. So K is this hyperparameter. that refers to how many of the nearest data points you will consider when classifying the new data point. So let's say that you're a book reader, and so you finished a book. It's a thrilling detective novel. So you go to the bookstore and you want to determine what's going to be the next book that you're going to read. And so now we get into this hyperparameter K. If we choose 5, then you look at 5 books in the store that are physically closest to the detective novel you've just finished. And so if they have these in some kind of an order, like you would if you go to the library, suppose 3 of these books are by the same author and 2 are a different author in the same genre. Since the majority, 3 of 5 or the nearest neighbors are from the same author, you decide to read another book by the author. And so that would be one example of how you would be thinking about it. So the author and say the genre. And so if you got both of those, that would be clear which one you would be going for. So this is just another example of showing the Euclidean distance. And we can be seeing a 2-dimensional or 3-dimensional example, but you could have this as many, quote, dimensions as you would like, as the different type of characteristics that you're going to be using to determine how you're going to classify an object. So the pros for KNN, it's easy to implement. There's no need to train a model, and it's versatile. It can be used for classification, regression, and search. And that's what we're going to be focused on. It's typically used for classification. That's what we're going to be doing. It does not scale well. That would be a con. It's which is the get into the curse of dimensionality. It's prone to overfitting. And so thus you don't want to have K get too big, and it's not suitable for large data sets or fancy predictions. And so sometimes what is called is a lazy algorithm. And so it stores the entire training set and does not build a model during the training phase like eager learning algorithms like linear regression, which I think you've already gone over. And during prediction, KNN must compare the new data point to all the training data points, which can be computationally expensive. So here is an example. Microsoft Copilot came up with the same idea. So if we wanted to be having a cat detector, and so the model is going to, if it's a true positive, this is what it would be like. If you have a dog, and it's going to be a true negative. But here is these other ambiguities. Is it a false positive or a false negative? These are the ones that you have to be concerned about. And so when you're evaluating performance, that's something that you have to be thinking about. So if you have like 95% of the data is either true positive or true negative, you could probably say that's working pretty well. And so you could be coming up with a confusion matrix and saying that, well, I think we're doing a noteworthy job that's a good enough of a giving the right classification. And so we'll go with that. The confusion matrix can be in 2-dimensional, it can be a number of dimensions. Or a number of classes. And so that's just trying to give you a little bit of an idea of that. So here is a visual example. So we have 2 parameters. And so we can see that K equals 1, K equals 5, K equals to 25. And so this maybe it gives you a better sense of just having a clear line between one and the other. But it comes at a penalty. And so, but you'll see an example in our first notebook that it will be maybe will be another way to help you get a sense of that. So, so machine learning models have 2 types of variables, knobs, that can be tuned to produce better predictions. And so we have this hyper tuning so that K value. And so that's what we have that we're using for this situation. And so that's the knob, the main knob that we're using. We aren't here talking about linear regression, but it has parameters, but no hyperparameters. And so that just gives you a comparison between linear regression, which I believe you've already covered in KNN. So just a couple pages summary this. And so small values of K can rely too heavily on the specifics of what training data happen to be used. And so maybe just think back on this chart for a minute and see you can observe some of that. Large values of K learn very little from the training data and overgeneralize. Even values of K can lead to ties, and it's best practice to pick values of K that are odd. K is a square root, and the number of training data points is a good starting point. It can balance attention between large and small K values. And the tension between small and large K is an example of a bias variance trade-off. And so we can be seeing this trade-off between a small K and a large K. So small K tends to underfit, large K tends to overfit. The variance tends to be high for small K and low for a large K versus the bias. It tends to be low for a small K and high for a large K. So finally, for the evaluation metrics, we can be looking at how accurate it is. We want to be looking at this, the true false positive and a true false negative. And so how well it actually does the determination of what we're actually wanting it to detect. And so this picture, I think, is probably a little bit easier way for us to be thinking about that. Any comments or questions on what I've covered? Hopefully that gives a little bit more insight. If you just want to give me a thumbs up, or if you have a question or comment, please feel free to share. All right, well, thanks, folks. This is kind of transitioning, getting into how we would do the implementation. And so this is a precursor for looking at some of the notebooks. And so I would recommend that you go into Canvas and open the KNN example. As a minimum, you could just be opening the HTML. I'm going to be showing you actually it live. And so this may help you to break this down. So this was something that I thought was helpful, is coming up with a more detailed approach, a bunch of different steps that you want to be taking when you're setting up a machine learning model and actually ready for it to go into formal use. So the first part is you collect the data and prepare the data. And this is where it can take a lot of work. You have to really finagle that data to make it so you can actually put it, first select the model and train the model well. So you need to load it. You need to decide which variables will be predictors. And so weight and height were an example of what I use for my detecting between a fish and a cat. You want to split the data into training and testing data. So how much do you hold for training? How much do you have for testing? Then you actually want to import the machine learning algorithm. So the first thing you have to tell Python to import the things for KNN, if that's what you're using. You want to set up the model parameters. So say like the K hyperparameter, and then you want to fit the model on the training set and test the model on the test data set. And so a visualization can actually be very helpful for that. And then when you get to the last part, you want to validate the model, evaluate its performance with some test data, and apply the model, and you can actually start to make predictions on some things that you actually haven't trained or tested with, and then voila, you've got that all working. So this is where it gets into some of the specifics of loading your data. And so this is where this doesn't show all of the things that you have to load. The Python related items. So this is just assuming that's there. And so you wanted to load the data set name. And so you have to be putting in that value. And so load the data and determining what the target is. And so we load in our data set into a pandas data frame. And you've already been through that. You guys remember pandas? Just give me a thumbs up if you recall that. I think that was one of the first topics you guys covered. Note that we include the target in the data frame as well. And so that's something that is shown here, just to give you a sense. Then you want to be choosing the features. And so this is where you want to be looking at the data. And so for the example that I've mentioned, using the height and the weight would be an example of some features that we think would work quite well. So I think that's about what I'll focus on there. I won't get into some of these other things here. So now we have the first time that we've heard about this sklearn. And so this is one of the things that we're leveraging from sklearn. We're going to import the k nearest neighbor classifier. And so that's going to be something that we want to be doing. Now we have the hyperparameter, and here we're going to be using the number 4. And we've already mentioned that it's best to use a odd value, but that's just giving you an example of the things that we can initialize the model with. And then we want to fit the test and visualize. And because KNN classifier is a supervised learning model, it must be given both the features and the labels together. And so that's a step that we want to be thinking about. Drawing a visualization, if you can, it really does help. So when building classifiers, it's often nice to visualize the decision boundary. And we saw an example earlier. We can do this by plotting 2 dimensions of the data and coloring the black background based on which class a new data point in the location would be classified as. And so let's say maybe this isn't the final solution, but we're going to start out by using two criteria and then plot it out, and we can get a chance to be seeing how that looks. So that's, and then finally, we want to be doing an evaluation, and sklearn has a couple things that you can be using: mean squared error. You can have, you can show a classification report and an accuracy score. And those are all the kind of things that we can be using in terms of our evaluation. Then we can use a model. And so say we can have some quote ground truth, but it's not in our training data. We know what it is, but we wanted to see, does it actually come up with a prediction that matches what we know it is? And so maybe that's the last of the giggle test to see if we're okay with it. And then after that, we go ahead and say that it's ready for use, and we go ahead and use it. So so thus we have the accuracy, the confusion matrix, and the classification report. Maybe at least starting with these might be a useful thing for us to focus on, but that's what I wanted to be sharing on. So that's a little bit more insight on KNN. Why don't I just do a quick around the world, around the virtual world here, Rune? You guys tracking? Is this making sense? Are you seeing, does that give you a little bit more insight into KNN? Or any questions that you guys have? Okay, well, I'm just going to finish up with a couple of charts, just focusing a little bit more details on scikit-learn or sklearn. And so this is some information directly from the website. And so sklearn is a powerful open source machine learning library for Python. And so this is, it's amazing. I've used MATLAB for doing some machine learning in Python, and with the Juniper notebooks, it's actually quite accessible, and it makes it pretty fun. And so it provides tools for various machine learning tasks, including classification. That's what we're going to be focusing on: regression, clustering, dimensionality reduction, and pre-processing. It's built on top of NumPy, SciPy, and matplotlib. It's also listed up here and is designed to be accessible and reusable in different contexts. And on their website, it just showed this, giving you a sense of how you can visualize things. So say if you're trying to classify, and you can see various ways. We're going to see an example in the first notebook where the data kind of looks like that. And so you can be seeing how that at least to the way this data is shown, it's showing a clear separation between the two. You can do regression where you're predicting a continuous valued attribute associated with an object, or clustering where we can have automatic grouping of similar objects into sets. And I'm not going to go over these next handful of charts, but just quickly flash through them. So we've talked about KNN, we talked about sklearn, we talked about some of these measures that we can be using to help us determine how well things are performing. There's things that we would want to be importing. And so from sklearn, we can have the train test split, the KN neighbors classifier, the KN neighbors regressor, that may be something, and metrics. These are all some things that we could be taking advantage of. And then there's just some more detailed things that we can be using. So that's a quick overview of KNN. And next, what we're going to do is we're going to be using, pulling up these notebooks. And I'm curious if folks could tell me, what do you guys tend to use for your IDE? What do you, I wanted to see if the artifacts that I saw when I was using Google Colab was unique for me or something that you guys have experienced.
We are currently using the Jupyter notebook from Anaconda.
Okay, yeah. So that's probably why I had to do a little bit of tweaking. So forgive that a little bit of tweaking, but I'll bring that up. And so why don't you guys pull up this notebook, and let me give you a reminder where this is at. So if you don't, you may act, I don't know how Anaconda actually imports it into second. When I start to get too many things, I start to get a lag on my computer. So here is the KNN notebook. Have you guys opened this before, or have you, if I was to open this up, it's going to look fairly similar to what, no, it's not going to open it. Shoot. Well, I'm not going to try and open that again. So this, guys can give me a thumbs up if you were able to get this open. Or have you guys played with these notebooks yet? Okay. And if you haven't, Isabel or David, can you describe, did you have to do a cut and paste to put this into Anaconda, or did you, how did you get it into the right format? I don't know how that, I haven't used that IDE, so I'm not sure how that import works for you guys.
Uh,
Can it read an HTML and then convert it, or what does it do?
we don't have access to the HTML because we only have the KNN PDF as far as on Canvas. So normally, Professor Ron would just pretty much open the Anaconda notebook and then we would just type side by side. So what she would type, we would just follow through and she would explain along the way.
Okay. Well, let me I accidentally closed Canvas, so let me open this. I'm going to walk through two worksheets. And the first one is going to be this one, but it's going to be in the format that's compatible with Google Colab. And so if you were to download that, um, you'll be seeing what I'm seeing. So um, so this is what has all of the data. So you could then cut and paste, copy and paste that into your IDE. So you can feel free to try that. This has just a little bit more of description on top. So to understand KNN for classification, we'll work with a simple data set representing gene expression levels. Gene expression levels are calculated by the ratio between the expression of the target gene, that's the gene of interest, and the expression of one or more reference genes, often household genes. This data set is synthetic and specifically designed to show some of the strengths and limitation of using KNN for classification. So let's just back up for a minute. So here we're trying to use a medical application. We're trying to be looking at some genes to help us make an assessment of say if a person is susceptible for cancer or something like that, if they express the genes in a certain form or another. And so they actually have a link for this. And so I believe that you have that link. No, it doesn't show that. So if you guys are interested, I can let me go ahead and do that. I'll just put this whole description in here into the chat. See if how the formatting comes out. So the first thing you have to think about is, well, what is my data set all about? What is this data that I want to be analyzing? And so this is giving a medical slash bioinformatics area to explore. And so I'll just leave it at that. So if that doesn't make any sense or doesn't interest you for that application, you can just be thinking this as just a sample data set that we're going to be utilizing. And so you want to import these things. So NumPy, Pandas, Matplotlib, and so the PyPlot and the Seaborn, those are the things that you want to be adding. And so I'm curious you need to get this data set. Is that something that you guys have access to or not? Not, I can, okay, Robert says he has the data set, so at least that's one of you guys are saying that. So good, you guys have that, great. So this command actually might work for you for whatever reason, since I have it in my Google Drive. It wasn't finding it, and I tried a couple different ways, and actually I found a workaround way to just come up with a file descriptor where it was located on my Google Drive, giving it public shareable access, and then voila, I was able to read it in. But I was getting an error with this, and so you can try one of these two ways. And so at least one or more of you said you did have this data, so you may want to try loading in this data. And so maybe just let me pause for a few minutes and see if you guys got that to work. Anybody? You can write down these lines of code if you want. In a separate cell. That's how you get us started. And if your folder convention is correct, you could use that. These are lines of code that are already in the HTML version that I showed you that you should have access directly in Canvas. Anybody want to give me some feedback whether or not that's working for you?
It's working for me on my end.
Thank you, David. Anybody else? You can just do a thumbs up if you like. Okay. Thank you, Isabel. Thank you, Nathan. Okay, so I'll just press forward a little bit at a time. So you've had the data frame loaded. So DF short for data frame, and so we load it with the information from the CSV file. And then with some of these commands, we can do head. So we just get the first couple of lines, first 5 lines, we can see what the data looks like. So if you've got the data to load properly, then this will work for you. And the DF describe, this just gives us a little bit more of the statistical information related to that. And so we have 2 genes, and we're trying to from that determine whether or not the cancer is present. And so now we're using the Seaborns. So Seaborns gives you nicer plots. It looks a little bit nicer than other alternatives you might have. And so this is what we get. And so thus you can see that there is some nice clustering, although you can see there's some cancer present way over here. And so maybe you could be thinking of this in a couple different ways. But the interpretation, where none of us are medical doctors here, but we can be starting to be thinking about this, and try and interpret that, but that'll be coming at the end. So let's see if guys were able to successfully do the DF head and the DF describe. Is that working for you guys?
You said the DFS is working?
Yeah, do these last 2 commands work for you?
Yeah.
Okay, good. This next command is a little bit more complicated, so I'll just put it in the chat. Or you could copy and paste from the HTML if you open that. And I would say that we've got some success going if you're able to get this plot to work. So as an introduction, I had mentioned that getting this kind of a visualization is really going to be something that's helpful to, this is a nice thing about having 2 dimensions or 2 categories that you're trying to get some perspective. And so you're not seeing some white space between these 2. So they're kind of on top of each other. That's going to make it a little bit more challenging. And yeah, I think these 2 are pretty close. I'm not going to copy and paste the other one, but this, I think with the version that you have, it only has 1. So then we want to be doing these commands. So let me just double check to see your version to make sure that. Yeah, you got all of these commands that are given. And so this is just a part of the recipe, if you will, for loading things in so we can be getting some insights with a KNN algorithm. So just make individual cells for each of these and put them in. So we want to, from the sklearn, we want to import the train test split and the standard scalar. Then we're going to be filling data in for capital X and capital Y. So the cancer present. So the X is not going to have, it's going to have everything except the cancer present. And so the Y is going to have the cancer present. Then we're going to be splitting the data into our training data for X and Y and our test data. And some of the capitalization approach is a way of helping us to make sure we don't get those mixed up. When we load from the standard scalar, we populate the scalar. So now, remember we talked about the importance of scaling the data. And so this is a way that it gives us, it scales things so we're going to be have a better success with our algorithms. And it's now we're getting to a point where we're going to be putting in the k nearest neighbor. So right now we have this set up for the k nearest class neighbor classifier has k equals 1. The default is 5, and so we can be playing with that, but we can just get this going here and see how that starts to work. Any questions or comments on that so far? You guys able to follow that? Any why don't you guys give me a thumbs up if you're tracking, or if you want me to slow down or go back, let me know. Okay, good. So then we get into thinking about choosing the hyperparameter k, what it would be the best value that we would want to be using. So the full test, we come up, the length of that is 900. And so we have the two genes, and then we are coloring the hue with cancer present, either it's 0 or 1. So we have that compared to what we had before. Okay, so we had a chance to first, we have the data, and I know this is maybe an area that some of you guys aren't familiar with, and so if say they take a biopsy and they're trying to figure out whether there are cancer genes or there are the right kind of genes that are supposed to be in that sample. And so they're trying to figure that out. Maybe just thinking that in terms of a context. So we import it, we get everything set up with our data set. We need to just get a sense to look at that a little bit clearer. And so here we can see there is a 1 or 0 classification for whether or not the cancer is present for the data. We got a chance to be seeing what the raw data looks like here. Got a couple example ways of plotting that. Then we needed to split the data into our training data set, our testing data. And so we have some neat things in sklearn that helps us to do that. So we went over that. Then we able to then have things set up where we can be looking at this data in a little bit more detail, see the outputs. And then finally, we have the model evaluation. So what is the accuracy score? And so for the Y test versus the Y predicted, it's about almost 90% accuracy. Then we look at the confusion matrix. And so a true positive and a false negative, those are the lion's share of that, but still we can see that these errors are maybe they're more than what you would want. And so maybe by playing with the K value, we can look at how we can get that to be a little bit better. And the last thing is we have the classification report, and I haven't really talked about that other than to mention that that is one of the things that we can be exploring. Anybody have experience or heard of a classification report? Is that something that you guys have looked at in sklearn? And if not, it's okay. But just
Yeah, the teacher introduced us to the classification report. Essentially just gives us like a graph of like the labels and showing us like the precision, the recall, and as well as like other types of other certain things that are added to the classification report. But essentially just to add like the percentages, the just the yeah, essentially the probabilities, I would say, um, in the report.
yeah, it just gives us some more information other than just the confusion matrix and the accuracy. So these are the 3 things that you would be utilizing together to try and give you a best sense of how well the model is performed. Okay. Any other comments or questions on that? See, the other example is one that I have that this is not something that's in Canvas. And so this is I'll go through this a little bit quicker and then see if there's any other comments or questions that people have about this or some other topics. So this is looking at sonar data. So basically you're trying to detect with the sonar sensors that you have, whether or not you're getting close to a rock or a mine. You know, neither one is good, but a mine's going to be explosives and a rock is you want to avoid. And so thus there'd be different things that are going to be part of your course of action for your submarine. So sonar, which stands for sound navigation ranging, is a technique that uses sound propagation, usually underwater as a submarine navigation, to navigate, communicate with, or detect objects on or under the surface of the water, such as other vessels. The data set contains the response metrics for 60 separate sonar frequencies sent out against a known minefield and known rocks. These frequencies are then labeled with the known objects that were beaming the sound at either a rock or a mine. The main goal is to create a machine learning model capable of detecting the difference between a rock or a mine based on the response of the 60 separate sonar frequencies. And there's a reference here. I'll go ahead and put this in the chat in case anybody would like to look at that. So ultimately, we're seeing a couple examples of the applications of machine learning. These may not be in your wheelhouse of thing that you would be interested in, but it just gives you an idea how widely applicable this stuff is. So we have the same commands we had before, loading the data into our IDE. For me, I had to load the data set a slightly different way. For a few guys, you would be using this sonar data. And here we can see just a sample of the first 5 lines for each of those frequencies, 60 frequencies that we can see that data. I used another command called df.info just to get an idea of what is in each one of those elements. And so you can just get a chance to be seeing that. So then we get into the data exploration. So we're trying to do a so this is a heat map of the correlation between the different frequencies. And so you can see that more or less there's not a lot of correlation if you have frequencies that are close to each other, maybe a little bit more, at least in certain areas. So this just gives us an idea of each of the 60 frequencies that are used in sonar. I had to finesse that a little bit. So this is just the code that didn't work for me, but it just would have, this is an updated version of that to make that plot come out. What are the top 5 correlated frequencies with the target? And so basically we can be seeing that here are the top ones. And so these are the ones we should be paying attention to. The other ones we don't need to really focus on. And so that kind of can help to reduce the complexity of what we need to be looking at. So we want to split the data into features and labels and then split into a training set and a test set with 90% for a cross-validation training and 10% for a final test set. And so that's what we have there. Then the next task is to create a pipeline that contains both a standard scalar and a KNN model. You can see how we can go about doing that. Next, we can perform a grid search with the pipeline to test various values of K and report back the best performing parameter. And so it's going to help us determine what the best K value is, and we're going to look at a range from 1 to 30. So so I won't get into too much detail, but then we can plot that out and figure out, well, what is the best K value? And so using the elbow, you can see that, well, maybe this one might be a K of 9 might be good. It's a lot more computationally more challenging to go all the way up here to 27 or so. But this is the first one that really takes a nice dive And so maybe that would be a good value for us to be using for this data. And similar to before, we finally can be doing our evaluation. We can be looking at the confusion matrix, and so and the classification report. Those are the two things that we can be highlighting with that. Okay, well, I think I'll stop there in terms of presenting some information. Just a couple reminders. I'm really sorry that Dr. Rawan was not able to do this lecture just for her health. But on the flip side, I'm happy to have a chance to be able to continue and pass the baton on to me for this one lecture for something that I think is really fascinating. I think machine learning is a really wonderful topic, and I wish you well as you're continuing to go through this material. Any other comments or questions that people have, or anything else you'd like me to highlight?
Well, good on my end. Thank you for helping us out.
Yeah, sure thing.
Thank you, Professor, for taking the time.
Yeah, sure
for-
thing. Okay, well, the Lord bless all you guys. I hope you have a good rest of your day, and I'll look forward to seeing you guys soon. Take care.
Thank you. Bye-bye.
Thank you, Professor.